Welcome to NCERT Reader. This question is 64 conducting dwarfs, each of radius 0.02 meter and each carrying a charge of 5 microcoulomb are combined to form a bigger dwarf. The ratio of surface density to the bigger dwarf to the smaller dwarf is. So whenever we have, suppose a charge Q is given here, and let's suppose this I am considering that R. So what is the surface charge density is? This is for it is this I'm considering here for the surface area charge density, not volumetric charge density. So it is charge per unit cross-sectional area it is. If I'm considering here 4 pi r square, so this will be the surface area charge per unit cross-sectional area it is. So that is the surface charge density whenever it is used to. In this question only, what is asking that 64 conducting drops. So here, if I'll consider this kind of drops, small drops are there. 64 conducting identical drops are having some radius small r, and it is forming that and having some charge small q, and 64 these identical drops are getting combined and it is forming a big drop, bigger one. And let's suppose the bigger one is having radius r. So what is the principle here? We can use that. We know that charge conservation principle. Charge is neither created nor be destroyed, and that whatever the charge, it is initial charge on the sphere, a smaller sphere. This is considered to be the Q initial, and here it is. Let's suppose I am considering Q final. So Q final will be the capital Q, and Q initial is the initial charge on the smaller sphere. So what we can apply over here is charge conservation. So this is one principle that we can apply. And another is that we are looking, the question is asking you find the surface charge density of the bigger drop to the smaller drop. So what will be the surface charge density of bigger drop? So sigma bigger by sigma smaller. This is the actual question asking you. And how to find sigma bigger? So sigma bigger के लिए हम लोग capital charge को रखेंगे 4 pi and capital R को रखेंगे, और sigma स्क्वायर के लिए हम लोग small charge को रखेंगे और 4 pi और small r square को रखेंगे. यहाँ से 4 pi get cancel out. So it is q by small q, and then we have a small r by capital R. ये एक्चुअल में निकालना है, ये एक्चुअल में निकालना है. तो हमारे पास जो चार्जेस है, व्हाट द चार्जेस वी आर हैविंग इज चार्जेस, इनिशियल चार्जेस, टोटल चार्ज जो है 64 है. तो एक पे अगर क्यू चार्ज है तो टोटल चार्ज जो क्यू इनिशियल है ये 64 टाइम्स क्यू है, और ये कैपिटल क्यू के बराबर हो जाएगा क्योंकि कैपिटल क्यू इज द बिगर चार्ज. सो व्हाट इज द रेशियो हियर वी आर हैविंग ऑफ द कैपिटल क्यू? So this will be equal to 64 q times. So capital Q by small q क्या होना चाहिए? It is 64. So this is the ratio of the charges what we have. It is, so it will be 64. And what about the radius? It is, so radius अगर हम लोगों को यहाँ पे equate करना है तो we can equate the what is it is called that volume. So what is the volume of this smaller charge volume? All the volume 4 by 3 pi r cube. इसको अगर हम 64 टाइम्स करेंगे तो वो वॉल्यूम बिगर वॉल्यूम के बराबर होगा. So that is the second thing here we can have that relation. It is, so 4 by 3 pi r cube. This is the bigger volume and this will be 64 times of 4 by 3 pi r cube, a smaller volume. So here we can see 4 by 3 pi is get cancel out here. So what is the value of r, a small r, actually a small r by capital R, this one. So this we can see here it is 1 by this is 1 by 64, and here we are having cube, so it will be 1 by cube. So this we can say that it is 1 by 4 to the power cube to the power 1 by cube. So this is 1 by 4. So this is 1 by 4. So here we are having this value is just, we can get the result here. It is, so q by q is 64, and a small r by capital R is 1 by 4, so it is 1 by 16. A square of that will be, so it is having 4 result. 4 is the result here. So 4 is the ratio. So sigma bigger by sigma smaller is 4:1. 4:1 is option B. So option B will be the result. So this is question basically ask you that you have the idea of the sigma, that you know the sigma or not, and you know the charge conservation or not, and once the smaller volume radius, smaller sphere are getting combined over there and making into bigger radius, bigger volume over there. So by that time, what the volume of a smaller will be there, it will acquire all the bigger volume. So volume will be equal. Then you have charge conservation. Two principle here we applied over there, and on the basis of that it is done. I hope you understand. Thank you.